I'm always a little surprised when a talk of mine actually gets accepted because I'm not sure it's actually as interesting to anybody else as it is to me. It certainly seems less important than a lot of stuff is going on, but thank you for coming, and I'm going to try and make this as quick as informative as possible. Before I start, a big thanks to everybody at Hope for doing all the stuff they do. Someone had to hang those lights. You know, the sound in the back of the room, it is ace, right? So thank you to the Hope people. Yeah, thank you to all the AV and everybody behind the scenes that we don't even know because they're doing their job so well we're not even noticing it. So thank you, everybody. When I was preparing this talk, a minute after I submitted it, I realized there's a better name for this talk, which is sensor overload, because I have way too many sensors to talk about. They're all fun, they're all cool, and some cool stuff you can do with them. So this is kind of fire hose, so I'm going to go pretty quickly. There's no real good way to arrange all this material. There's no good skewer through the shish kebab, so I've kind of arranged it like this. It's not actually a 3-day talk, although I could talk for 3 days. We're going to start kind of with photosensors, just stuff you can do optically. We're going to do chips and MEMS, and then there are all kinds of other crazy stuff, and then finally we get back to optical stuff again. So a little bit about me. Credentials don't matter. I'm a tinkerer, I'm a hacker. I do robots for fun, and I do robots for a living. I like making art robots. I like making cocktail robots. These things here that you're seeing are not actually cocktail robots. These are surgical robots. These are prototypes of a system that uses a high-pressure water jet to remove tissue. And this is probably the most terrifying day of my life, where they're using my janky code on a real human being. All right, so I need to reassure you that once we got funding for this company, it's called Procept Biorobotics, they hired the grown-ups and the people who knew what they were doing, so there's no chance of my janky code getting anywhere near your tender bits. So relax your mind and let's float downstream on the fire hose. Okay, I'm going to talk, as I said, about the first part is going to be optical sensors. Now, everybody has seen these or used these, and they turn out to be kind of everywhere. That first thing at the top there, that's you just have a LED which shines on the photodiode. The photodiode looks like a switch. When the light hits it, it turns on. This is easy to interface to a microcontroller, to an Arduino. It needs a couple resistors, but a bunch of how-tos. You see this everywhere. That kind of interrupter thing, there's one in your printer that tells you when it's out of paper. This thing in the middle there's one in the bathroom which flushes the toilet when you stand up, or it's supposed to do that, right? Sometimes it doesn't. So this kind of thing where you have this, either this interrupted thing where you have a beam of light which is blocked, or you bounce a beam of light off something else, you pick it up. Very common design pattern, we'll see it a lot. Here's something I did with this kind of retroreflective thing. There's a whole bunch of sensors arranged in a sphere that you can do cool things with. This is a recent interest. This is called PPG. Let me see if I can not mess this up, which is a photoplethysmograph, which basically measures your heartbeat by detecting when your heart pumps blood through your finger or another part of your extremity. It absorbs more or less light, and you can detect that with an optical sensor. There's this transmissive thing, goes right through your finger, and there's also a reflective thing. This is what on your Fitbit, what's on your Apple Watch. This is kind of hard to do because the actual change is very, very small, and so you need to do a little bit of finesse to actually pick up that signal, but you can do it. Here is something that you can buy. It's not very expensive if you want to experiment with this stuff yourself. I got one of these because I'm doing an art project using this to make stuff beat in time with your heart. I also got this, which is super cool. This is a pulse oximeter. This measures how much oxygen is in your blood as well as your pulse in real time, and has streaming data. This was very inexpensive. My doctor wanted $400 for something like this for one night, and you can buy this for $30 and wear it for a week and get used to it. The software it came with was not great, so I cracked it. I didn't crack it, I just man in the middle. The serial protocol wasn't hard. If you want to do this, it's online on my GitHub. Let's see, what is next? Optical encoders. These are super fun. They're everywhere. Every robot arm that has a joint has to know where it is, what angle it is at. And this is quite often how they do it, using these optical encoders. And these are very easy to interface to a microcontroller. You have these two of these interrupter things, and they're interrupted by this slotted disk you can see in that middle picture there. When they turn in one direction, they're in one phase, and when you turn in the other direction, it's the other phase. So typically what you do is you put one of the signals to trigger the interrupt, and when in the interrupt, you look at the phase of the other signals. If it's high, you increment a counter. If it's low, you decrement the counter. Super easy, really works. But these don't tell you where you are. They only tell you how far you've turned since the last time you knew where you were, and we'll talk about that later. But here's a project that I did. Actually, my friend Charlie made this giant thing using hydraulics, and we didn't want to crush any Coachella bros, so we made a 12, this thing is giant and it moves with hydraulics. There's 12 different joints on them, and did a little feedback thing with that optical encoder to tell you how far that was over and whether to turn on or turn off that hydraulic valve to move it to the place it should be. Okay, this is something a little fun. This is a distance sensor that uses optical thing. It basically bounces off something in front of it and measures kind of the angle. I'm not actually quite sure how these work. I think there's a little microprism array in there. One of these days I'll take one apart and figure it out. But these are not expensive. These are fun. I can imagine all kinds of uses for these. Maybe someone will put one on a conference badge and measure how far the person is in front of you. You might have to discount for the reflectivity of black t-shirts, but maybe light up a little LED depending on how close they are to your personal space, and you can kind of dial that in. I don't know. All kinds of fun stuff you can do. Sometimes you don't need a camera to pick up light. This is kind of a 1 pixel camera. This color sensor, shout out to Adafruit for open source hardware and making this really easy to use. And there's code on the Adafruit website for using these sensors. This is a 1 pixel camera. It has 16-bit color resolution, red, green, blue, and all bandwidth. You'll notice on the right there, that thing that says SCL and SCA, that is a very standard serial protocol called I2C. It makes it really easy to use. Quite often somebody has a library for interfacing. In this picture on the lower right there, that's Arduino, and you see the SDA and the SCL serial data and serial clock. All you have to do is hook those up and make sure you're on a common ground, and things will usually work the first time. It's kind of amazing. And almost all these sensors that I'm presenting, somebody has already written a driver. You basically talk to them by writing registers, and somebody's figured all that out, or it's not too hard to do that by reading the data sheet. All this stuff is pretty easy to use, surprisingly easy. Okay, here's an application of a color sensor that I think is super great. This was a interactive installation done by Micah Scott, Scanlime. That thing on the right there, that's a giant interactive wall, and those things are knobs. You turn them, those circular discs. So she needed a lot of position sensors to detect what angle that these things were at. And so she did this ingenious hack with a color sensor. She printed out these colored sheets behind these things, and they're big, and then so depending on what color the color sensor sensed, you could tell what angles these were. They didn't need to be very precise, but this looked very robust, and this is a really nice hack, so I love this. See, what else? Cameras. Cameras, a whole talk in themselves. Just a couple things I wanted to point out. Raspberry Pi and PiCam, there's this thing called Motion OS, which lets you do a streaming camera if you want one for your doorbell or your laundry room or something, and you don't want to be part of a botnet, or at least less likely to be part of a botnet. You can roll your own, and that's super cool. OpenCV, computer vision library, very powerful. People have been working on that for 20 years, does really amazing stuff. YOLO is a neural network recognition library. I haven't used it myself, but the demos look really awesome. This thing works at 30 frames per second, and it can detect things like bicycles, a car, or that funny shaped cat there in that picture there. And there's also other things, cameras that use structured light to detect depth, and that's like the Real Sense and the Kinect. That's a little bit out of scope of this talk, but I thought I'd mention them anyway. Moving on, OpenMV camera. This is a camera with a super powerful ARM processor that's doing some image processing right on the board. You can take this and hook it up to an Arduino. There